basically
So if you say optical isomers that will be needing a chiral
like,
carbon, right? What's a chiral
yeah,
carbon? A chiral carbon is a carbon which has got all four groups different, right? Isn't it? Fine.
yeah,
You get my understood? All four groups different. This is a chiral carbon, right? Isn't it? You get my point? What's a chiral carbon? Chiral carbon
yeah,
is a carbon which has got all four groups different, right? Clear?
yeah,
You get my point? Understood this thing? All four groups different, right? This is clear. Now, secondly, you have to understand that if you're seeing that if you take a optical suppose this is a chiral carbon. If you're having a substance with a chiral carbon, it can lead to optical isomer. What is optical isomer? If you have the same isomer but a different molecule you're having, where this this group is facing each other. Is it clear? Understood? Clear? Get my point, right? You can understand this thing. Understand what I'm saying? In the optical isomer, what happens? This is a chiral carbon, and if you have got the same molecule where it is just a mirror image, is it clear? Understood? By luck. Understood? Did you understand this thing, man? If you have got a molecule like this, and stunningly, if you got another molecule which has got just a mirror image, understood to each other, right? Clear? Is it clear to you? Right?
yeah,
Means the configurations are opposite. Can you see this? This is in the front side. This is in the back side. What is there here? Back side, front side. Is it clear? You got
yeah,
understood this thing? So these will be giving rise to optical isomerism. What is optical isomerism? Optical isomers are those isomers which will be rotating the plane polarized light in opposite direction. Right? Clear? And understood? What is plane polarized light? You to understand? If you take a normal light, right, or ordinary light, ordinary light will be having the propagation in all directions, right? Clear? Understood? All directions. Understood? Got it? Will be propagating in all directions. Clear? Understood? Clear? All directions, right? Clear? Propagating in all directions, right? Clear? Understand this thing, right? Propagating in all directions, right? But if you put a normal light, if you put a normal light in front of a polarizer, right? Understood? Polarizer, right? Clear? What happens? This will be now doing what? This will be eliminating, right? Eliminating all the propagation excepting one. Understood? Clear? To get my
yeah.
point? What then? This is called as the plane polarized light. What do you mean by plane polarized light? Can you quickly tell me? What do you mean by plane polarized light? Tell me. What is the plane
It's
polarized light? Bolo. Plane polarized light is what? When you put an ordinary light, it has got many planes of propagation. Understood? Suppose you are drawing a bulb. See, it will be having many planes of propagation, right? Clear? Understood? The light will spread it out every direction, right? Clear? When you place a normal ordinary light in a polarizer will be cutting off all the propagation, plane of propagation, excepting one. Is it clear?
so
Do you
there's
get my
only one
point? One
thing.
propagation, plane of propagation, right? This is called as plane polarized light. Now, if you place one optical isomer, one over here, right? And if it rotates the plane polarized light to the left by 30 degrees, right? If you place the another optical isomer, right? Two, it will rotate the plane polarized light in opposite direction. Understood? If it rotates by
Yeah,
minus 30 degree, it will rotate by plus 30 degree. Understood? Clear? Fine. What is optical isomers? Optical isomers are those which rotates the plane polarized light. Clear? In opposite direction. Okay? One. Good to get my point? What is optical
yeah,
isomers? Fine. Optical isomers will be having a chiral carbon. What's a chiral carbon? Chiral carbon has got all four groups different, right? Clear? You get my point?
yeah.
Understood this part, right? Clear?
Yes,
Do you get my point? Right? So this is very important, right? Huh? Understand this part? You'll have got all four group different and will rotate in the opposite direction, right? Now mine, if you mix optical isomer 1 50%, if you make optical isomer 2 by 50%, right? This mixture does not rotate the plane polarized, right? Okay? This 50-50 mixture of this optical isomers, right? This is called as a racemic mixture, right? Understood? What is a racemic mixture?
oh,
Understood? Hmm? You get my point?
how
If
do
you
you
take,
spell?
I'm going to it. See, this will be coming in a boards, right? This one. Can you read it loudly from here? From here. Here. Oh, so here you do it, right? A little better. Read from here. Read loudly. Fine, read it loudly.
Um, A carbon atom attached to four different atoms or group is known as chiral, is alternatively known as asymmetric or as stereocenter. The four groups arranged tetrahedrally around the carbon atom with bond angles of 109.5 can be arranged in two different three-dimensional configurations with a mirror, which are mirror images of each other. This is known as optical isomerism. The term refers to the way in which the isomers interact with the plane polarized, right? Which will be discussed below. They're said to be chiral molecules and have no plane of symmetry.
Now read. Read.
If you look at your two hands, you will see that there are mirror images, and when you put them on top of each other, the fingers and thumbs do not line up. We say they are non-superimposable.
Hmm. Did my non-superimposable, right? Now right. Now read.
So I can't see the okay. Yeah. The same is true for optical isomers, and the two non-superimposable forms are known as enantiomers. Um, a mixture containing equal amounts of the two enantiomers is known as a racemic mixture or a racemate. And we will see such as a mixture is said to be optically inactive.
Inactive, right? Clear? This will be rotated towards the left-hand side by minus 30. And this 50% will rotate to the plus 30. So what happens? This cancels out, right? So the
Yeah.
plane polarized light does not rotate. Clear? You get my point? Understood?
Yeah.
Now, if you got chiral centers, right, in more than one carbon, right? More than one carbon, right? And if you have got another molecule which has got opposite configuration at each and every chiral center, right? See, this carbon has got a OH group in the front side, this back side. Now this carbon having what in the back side, this front side. Is it opposite configuration? Yes.
Yeah.
Now check this carbon. This has got a configuration of front side, back side, and this is back side, front side. So it has got opposite configuration at each and every chiral center, right? Clear? Understood? Chiral center clear. Is this a chiral center? Right? Is it having all four groups? Four groups different, right?
Yeah, it's all four groups are different.
Different. So it's a chiral, right? Right. Got it. And if you have got opposite configuration each in the chiral center, so this molecule and this molecule will be called as enantiomers, right? Clear? Understood? And if you have got one of the carbon, right? One of the carbon. This is opposite configuration. Opposite configuration. Now check this. Same configuration, right? Fine. So this is
Yeah.
not a enantiomer. This is a diastereomer, right? Clear? These are not optical isomers. Okay? Clear?
Oh, okay.
Got it, Mine? Understood.
Yeah.
Can you open the question paper, please, quickly? Mine, can you send me a message, please? ये कर लो माइन GD से कर पाओगे ना send me a message. Mine, whatever I'm telling you, I'm just you have to if you respect me, if you have to do it, Jilly, right? Send me a message. Stereoisomers, page 516, 5162, 522. Have you written?
22 or 22? Oh, 22.
522, 523, huh? ठीक है? Right, mate?
Okay. Yeah.
This is the part you have to do, right?